Hello everyone, my name is Jubin Biju. I am going to present PPT on open circuit test and short circuit test of a single phase transformer. I am from Guru Gobind Singh Polytechnic Nasik, guided by Professor Sunil Morisar. This PPT we are going to present two topics, that is equivalent circuit diagram of single phase transformer and open circuit test and short circuit test. First, equivalent circuit of single phase transformer. As we know that in transformer there are three main parts such as primary winding, secondary winding and iron core. So here we can see primary winding circuit and secondary winding circuit. R1 is representing primary winding resistance, XL1 representing primary winding reactance. It is also called as leakage reactance of the primary winding. R2 representing secondary winding resistance and XL2 representing secondary winding reactance. I1 is current flowing through the primary winding, whereas I2 current is flowing through the secondary winding, and load is connected in the secondary winding. So now if we want to analyze the transformer, then we have to work on both the winding, primary winding as well as in the secondary winding. So then only we can analyze the transformer. But it is convenient that if we transfer secondary winding parameter to the primary side, or if we transfer primary winding parameter to the secondary side, then we have to work on any one of the winding. So it is convenient for us. After that, we can find out equivalent circuit of a single phase transformer for the analysis. So in this case, we are going to transfer secondary winding parameter to the primary side. We will analyze primary current as I1. So we know that I1 is equal to I0 plus I2 dash. So here we are just separating I1 is equal to I0 plus I2 dash. So first part of I1 is I0. Now I0 is nothing but the no load current. This no load current of the primary winding having two components, I mu and IW, where I mu is called as magnetizing component and IW is loss component at the no load. I mu and IW are the two components of I0. So the IW current is flow in the resistance, and that resistance is represented by R0. So R0 representing the open circuit resistance, and I mu is flowing through the inductance, that is X0. The function of I mu is to produce flux in the iron core, and the function of IW is to produce losses during the no load. This is the first component I1, that is I0, and next component is I2 dash, is nothing but the load component of the primary current. So we separated the primary current. Now in the secondary side, in the secondary side also we are having a different parameters. So let us transfer secondary winding parameter to the primary side. So we are transferring R2 from secondary to primary. So we know that we cannot simply transfer R2 from secondary to primary. We have to transfer its equivalent. So when we transfer R2 from secondary to primary, its name will be R2 dash. Similarly, if we want to transfer XL2 from secondary winding to the primary side, we have to transfer its equivalent. So its name will be XL2 dash. Now we have transferred R2 and XL2 from secondary winding to the primary side. Now R1 is primary winding resistance and R2 dash is secondary winding resistance, but refer to the primary side. So together will constitute the equivalent resistance of a transformer, and it is represented by R01. R01 is equivalent resistance of whole transformer, but refer to the primary side. Similarly, XL1 is a primary winding reactance and XL2 dash is secondary winding reactance, refer to the primary. So these two will constitute the equivalent reactance of the transformer, but refer to the primary side. So it is called as X01. R01 and X01 available. So this R01 and X01 together constitute Z01, whereas Z01 is nothing but the equivalent impedance of the transformer, refer to the primary side. So we transfer parameters from secondary side to primary side, so the load is connected to the secondary side. So we can transfer secondary connected load ZL to the primary side. So E1 will be equal to E2 dash. After transferring this parameter from secondary winding to the primary winding, we are getting the equivalent circuit of the transformer, but refer to the primary side. We need to draw a equivalent phase of single phase transformer. We have to calculate then R0, X0, IW and I mu, then R01, X01 and Z01. If we calculate the 7 parameters, then we can easily calculate or obtain equivalent circuit of a single phase transformer. And to find out these parameters, we have two tests, such as open circuit test and short circuit test. Open circuit test. Open circuit test of a single phase transformer. So, as the name suggests, in the open circuit test, one winding of a transformer has open circuited. Here we are keeping secondary winding of a transformer as open. Here we have applied a rated voltage. So what is rated voltage? So if the transformer is given by a 230 by 115 volts, so it means 230 volt is rated of primary winding and 115 volt is rated of secondary winding. So we are applying rated voltage in the primary side. So when we apply rated voltage in the primary side and secondary side is open, so we know that the formula of I1 is equal to I0 plus I2 dash. I2 dash is given by K time I2. As I2 is equal to 0, so I2 dash will be 0. So and I1, that is primary current, will be equal to only I0. So I0 is called as no load current of a transformer. So this current is very small. So very small amount of current, that is I0, is flowing in the primary winding, and there is no current flowing in the secondary winding. It means that current is flowing in the transformer is negligible. So there are two types of losses in case of transformer, that is iron losses and copper losses. So as negligible amount of current flows in the transformer during open circuit test, so we have neglect the copper losses. So copper losses in the open circuit test is negligible. So next has we have applied rated voltage at the primary side. So the flux in the iron core will be rated or normal. It means that the flux present in the iron core depends upon the input supply voltage, and the input supply voltage we have given rated voltage. Therefore the normal and the rated flux exist in the iron core, and iron loss depends upon flux, and as a normal flux is there in the iron core, we are getting iron losses. So in open circuit test we shall easily get iron losses. How to perform this open circuit test? Now first of all we have to take a supply, that is 230 volt 50 hertz AC supply, which is available. We never give supply direct to the transformer. In between we use a dimmerstat. Now what is dimmerstat? Dimmerstat is an example of a transformer only provision. In that we can change the no number of turns in secondary side. If we change the turns of secondary side, then we can vary the secondary voltage. So by adjusting the jumper we can gradually increase the voltage from 0 to required value. This is use of dimmerstat. We have to provide supply to the transformer. So we have transformer in a primary and secondary side, secondary winding. So basically if we connect the meter in the primary side and secondary side, connecting it in a low voltage side, so has a rated voltage has to applied. So if we are connecting in a low voltage side, then we have to apply 115 volt. But if we want to connect it in the high voltage side, then we have to apply 230 volts. So it is convenient that to perform the open circuit test the primary side. We are performing open circuit test on the low voltage winding, that is 115 volt. So to measure the amount of current we need a ammeter. We need a ammeter to measure the amount of power. We need one wattmeter. Wattmeter terminal are MLCV. Now this is the wattmeter. Now we are closing circuit. So to measure input voltage we are connecting voltmeter. Now we have to keep secondary winding open circuited. Now as secondary side is open circuit we have to connect a voltmeter. Internal impedance of voltmeter is maximum, so current flowing through the voltmeter is 0. It means by connecting the voltmeter, the secondary winding is as good as open circuited. Now the procedure is after closing the switch, the supply is given to the primary winding. But as we know, in the open circuit test we have rated voltage. So rated voltage of a primary winding is here, that is 115 volt. So it is nothing but it is represented by V1. So this voltmeter will measure the value of V1. Now in the open circuit test, small amount of current flows in the primary winding, that is no load current. It is nothing but the I0. Ammeter will be read the value of I0, and wattmeter will be read the value of power, that is no load power, that is represented by W0. In open circuit test only iron loss take place. That is why the wattmeter reading is nothing but the iron loss. So the wattmeter giving us iron loss. Now how to find the required parameter? So we know that P is equal to Vi cos phi. So here we can write down W0 is equal to V1 I0 cos phi 0. W0 is available from the reading of wattmeter, V1 is available from the reading of voltmeter, and I0 is available from the reading of ammeter. So simply we can find out cos phi 0 is equal to W0 upon P1 upon I0, and we can find out I mu is equal to I0 into sin phi 0, and IW is equal to I0 cos phi 0, and R0 using the formula V1 upon IW, and X0 using the formula V1 upon I mu. So we get these four parameters from the open circuit test. Now the short circuit test. As the name suggests, we have to keep the secondary side short. Means we have to keep one winding has short circuited. When short circuit in the secondary winding, we have to apply rated current at the both the winding. We have to increase supply voltage so that the rated current should flow primary winding and secondary winding. But to flow this rated current in the primary and secondary winding, we know that I1 is equal to I0 plus I2 dash, and I2 is maximum because secondary side is open, so reduce the amount of voltage is required to flow the rated current in the short circuit test. Both the primary winding and the secondary winding, so the reduced voltage is applied in the primary side. Now the rated current is flowing in the primary winding and rated current flowing in the secondary winding. So current cannot be neglected down because rated current is flowing in the primary winding as well as secondary winding, but has been given reduced amount of voltage in the primary side, so the flux exists in the iron core is very small, or reduced flux is there in the iron core. Regulate the iron losses. So iron losses is negligible but has rated current flowing in the primary and secondary winding. The copper losses will be take place. So in case of short circuit test, to perform the short circuit test. Now again we are having supply of 230 volt 50 watt AC supply. Again we are using thermostat, then primary winding and secondary winding, but we know that voltage ratio and the current ratio of a transformer is inverse. V2 upon V1 is equal to I1 upon I2. So it is convenient to connect the meter in the short circuit test at the high voltage winding. What is the reason? Because in the high voltage winding, current is low. Low current has to be given to the transformer. So it is convenient or always that the short circuit has to be performed on the high voltage side. So we are connecting the meter at the high voltage side, that is 230 volt side. We are using a ammeter to measure the current, and using a wattmeter to measure the power. Then we are closing the circuit. Voltmeter is connected to measure the value of input voltage, and ammeter is connected at the secondary side. Has ammeter internal impedance is minimum, so it has a good has short circuit. So now how to perform this test? So when the switch is closed, after switch is closed, we know that we have to apply rated voltage, and to apply rated voltage, small amount of voltage is required. So the voltmeter will reduce voltmeter will measure the value of reduced voltage. It is represented by VSC. Now rated current will flow in the primary winding, so ammeter will measure the primary current. That is why I1 and wattmeter will measure the value of WSC, that is short circuit power. Circuit test, the power loss is nothing but the copper losses, and secondary current is I2. So secondary ammeter will measure the value of I2. So how to find the parameter? So copper loss is given by I square R, and WSC can be written as I1 square R01. R01 can be calculated by WSC upon I1 square. Similarly, Z01 is equal to VSC upon I1. VSC upon I1. So X01 can be find out using the formula under root Z01 square minus R01 square. So here we are getting the remaining three parameters such as R01, Z01 and X01. PPT, we have seen equivalent circuit diagram of a single phase transformer, and to find out the equivalent circuit parameters using two tests, that is open circuit test and short circuit test. And the advantages of open circuit test and short circuit test is that we don't need to connect the load.